Hello everyone, let us see about in this video for common synthetic strategy for nanowires. Introduction. Nanowires are one-dimensional nanostructured with diameters in the extending nanometer range and length extending to micrometer. They exhibit unique electrical, optical and mechanical properties, making them promising for various applications including electronics, photonics and sensors. Several synthetic strategies are employed to fabricate nanowires, and the choice of method depends on the material, desired properties and application. Here are some common synthetic strategies for nanowires. Common synthetic strategies: vapor liquid solid growth, solution liquid solid growth, hydrothermal and solvothermal synthesis, electrochemical deposition, template assist method, direct self assembly, laser ablation, gas phase synthesis. Vapor liquid solid growth principle: catalytic assist growth in a vapor phase. Procedure: a vapor containing the precursor of the nanowire material is introduced. The precursor absorbed onto catalytic nanoparticle, commonly gold, silver, other metals on a substrate. The precursor decomposes and the material is deposited at the catalytic sites, leading to nanowire growth. Applications: semiconductor nanowires for electronics and optoelectronics. Solution liquid solid growth principle: catalytic assist growth from a solution. Procedure: a solution containing the precursor is prepared. The solution is brought into contact with a substrate coated with catalytic nanoparticles. The precursor decomposes at the catalytic sites, resulting in nanowire growth. Applications: semiconductor nanowires, especially for flexible and low temperature applications. Hydrothermal and solvothermal synthesis principle: nanowire growth in a high temperature and high pressure liquid environment. Procedure: precursor solution are heated in a sealed vessel. Elevated temperature and pressure promote the growth of nanowires. Application: metal oxide and semiconductor nanowires for various applications. Electrochemical deposition principle: electrodeposition of nanowires onto a substrate. Procedure: a conductive substrate acts as one electrode and a counter electrode is immersed in a electrolyte solution containing precursor ions. Nanowire growth at the substrate through electrodeposition. Applications: metal and semiconductor nanowires for electronics and sensors. Template assist method principle: using template to guide nanowire growth. Procedure: template, often made of porous material, are prepared. Precursor are introduced into the template and nanowires growth within the template. Template removal result in freestanding nanowires. Application: metal, semiconductor and composite nanowire with controlled dimensions. Direct self-assembly principle: utilizing molecular self-assembly to direct nanowire growth. Precursor: molecule or nanoparticles with specific affinities are designed to self-assemble into nanowire structure. The self-assembled structures serve as template for nanowire growth. Application: bottom-up fabrication of nanowire arrays for various applications. Laser ablation principle: nanowire formation through laser induced ablation of a target material. Procedure: a laser is used to ablate a target material. The ablated material condenses into nanowires. Applications: metal, semiconductor and carbon nanowires with specific properties. Gas phase synthesis, chemical vapor deposition CVD principle, nanowire growth from gaseous precursors. Procedure, gaseous precursors are introduced into a reaction chamber. Nanowires growth on a substrate as a result of chemical reactions. Applications, semiconductor nanowires for electronics and photonics.